So today we are going to talk more about some built-in Python functionality. Basically, the whole purpose of these 2 days is to introduce you to enough functionality in Python to allow you to do the majority of the work you would ever need to do. It's by far not like a complete guide of this is the entirety of Python, but I think there's enough here to get you started and get you into like reading more of the docs and understanding or finding other more specific functions that you might find useful. So yesterday we talked about the data types. We talked about lists and dictionaries and how to iterate through them, how to add and stuff like that. One thing I want to start off with is something that we didn't mention really yesterday, is how you can find something more easily in a list. So a lot of times when you have a list, you could either loop through every single item and compare to see if that element is there, or you can use like a built-in method, but there's also a way to do it where you can just ask. So let's say if we have this example list, so just modes of transportation, and it's as simple as asking if car in modes of transportation. So this will return either true or false based on if this element is in the list. And then you can do whatever you want. So let's say I can return true here, or I can print true. And similarly, if you have a dictionary, I'll show you here. So this is from yesterday. I switched it around. So if you want to look through the keys, you can do something similar to this. So if, let's say, donuts and foods, so this is my food dictionary. This type of, so if you're just looking in foods, it will look in the keys of this dictionary. So it'll look for this and print true. And we can also look through the values of this dictionary. So we can look through these items here. So we can say if in foods dot values. So the values function will return all the values in a list, basically, and this will be looking through a list of values. And then we can. So if I just run this, hi, then we get all trues because all of these things are in there. With a dictionary, you also have the dot keys, which is going to be the same thing as just having it without it. So if you just put it as it is, it'll do that. But if you have a need to, let's say, only grab a list of keys from a dictionary, then this function, that's where it comes in handy. All right, these were pretty simple. Not too much here. Let's see. Is that for now? Okay. So yesterday someone mentioned switch cases. Can anyone tell me what a switch case is? Best guess.
It's like, sort of like an alternative to a bunch of like nested if-else ifs.
Yeah.
But then
so
you can combine them too, so that it'll execute multiple cases if you want.
Yes, definitely. So with switch cases, I think this is only available in Python 3.8 and above. So if you are like, if you write a switch case and it's not working, then you need to update your Python version. So let's say I have this example here. So we're gonna get some input from the user asking what is the programming language you want to learn. And then we want to, based on the input, we want to print out something. So instead of having like if lang equals Python, and then afterwards elif, just keep going, like if, else, stuff like that. Instead of all of that, you can use match. So we are going to match this variable lang to a bunch of different cases. So there are a bunch of possibilities that I already know what I want to, what's it called? I already know what I want to compare it to. So you would put case, and then you can put Python here. And then whatever is inside of here will execute if this variable matches this one here. So here, I don't know, you can a data scientist. And so on. So you can keep adding these cases. JavaScript. Oops. You can become a web dev, something like that. And so on. You can add as many cases as you want. And if you want a default case, so if it matches none of these and you want just a default print statement, you put an underscore. And this will allow you to put all languages are beautiful. So now, get some information. So let's say I want to do Python. Prints that for me. If I just say something else, it prints the default case. I don't remember the exact syntax for, here, let me see, to do multiple comparisons. Let's say color, what's your favorite color? I think you can put comma color here. I will need to actually look this up. But basically, you can do this on your own. It's not really that important right now. But basically, you can do multiple things that you can check for. Any questions on switch cases?
Yes, these don't use break statements at all.
You can, but you don't need to. So the break, actually, you don't need to here. The break is only if you had this entire thing in a loop, maybe. Then you can break. So let's say you were writing a command line interface. So you are writing basically a program that will run forever until you quit. So let's say while true. And then it will get input from the user. I'm gonna just this lang here. Over here, I'm gonna comment these ones out. So let's just say I have a program that will run forever until someone puts in what is it called? Like this case. So it doesn't recognize what it is. So then you can put the break over here and it will break out of this loop. So you don't need a break for the match case because it's only going to go into the case that you need, or it will go into the default. So if I run this, what's programming language that you want to learn? I'm going to say Python. So it prints that out. I do JavaScript. It's still inside of the while loop, but if I give it something random, it's going to go to the base case and then it's going to exit out of this loop. Great question. Yeah. Any other questions?
Yeah, I just had a quick question from
Mhm.
the earlier example where you were talking about the dot values for what was it, for dictionaries.
Mhm.
If you're able to find a certain value, is there a way to see which key that value is associated with, or no? Unless I like loop through and see if that value is now equal to key in.
That is a great question. Let's see. Python dictionary dot values get key.
It's like off the top of my head, I was thinking you can just do an if statement and then check for each and every key, and if it equals that value that you were able to find, then have it input. But I was wondering if there was like a more succinct way to say it.
My answer would be there might be, but it seems like for all of these, it's there is an index one, an index method, but I don't know. Yeah, we might need to look into this a little more later.
Okay, no worries. Thank you.
Yeah, so the index position, I think the position is the key. So if you do, let's see. The foods dot index, and if you had, say, no, that's not what I'm looking for. Oops, copy this. So basically I'm looking for the value and I want to see if it will print out the key for me, right? Okay. Dictionary. Okay, yeah, we'll look into this. Remind me later and we'll look it up. All right. Okay, let's move on to the next thing. So the next thing that we're going to talk about is lambda functions. So lambda functions are basically like one-liner inline functions that you can use. The lambda functions, they are temporary. Huh?
Are these like big arrow functions in JavaScript?
Similar to them, yes, yes. So they are temporary and they're unnamed anonymous functions, basically. So let's say I have a regular function. Add one, it'll take a number. We've seen this function before, and then we'll return num plus one. So here I can just print out, add one, let's say 6. And let's say I wanted to define and add two functions. So this function is very small. It only has one line basically. So instead of defining it with a proper function definition and having it be like an actual function, you can just define a lambda. So you literally just write lambda and then you put what you want this function to do. So first you put what variables you're going to receive. So you can just give it an X. You don't have to give it like any specific name. I can actually just call it num if I wanted to. And then num plus 1. So basically, before the colon is the variables that you're going to take in, and then after the colon is what you want to return. So that's pretty much it. So now if I wanted to print add 2, I know here we're still giving it a name, but this is just holding it in a variable temporarily. And then you can just send in something. And if I print this out, oh, this is still running. So print it out 7 and then 9. So you won't really use this a lot in regular programming, but you'll use it within other functions, which we'll see in a sec. So you typically use it when you just need a function inline. Like you guys said, very similar to the fat arrow function in JavaScript. Any questions on this real quick?
Could you have like multiple parameters besides num? Could you have like another one?
So let's say I want this function just to be add, and I want to send in number, num, and then a second number, num2. I can say num plus num2, and I can call it and send in 2 variables. I should probably stop that, but no, okay. So it added them to 10. So yeah, you can add multiple variables. So yeah, before the colon parameters, after the colon, what that function will return. Okay, so now let's see. Oh yeah.
Question before you move on. If the parameter coming in as a list or an iterable,
Mhm.
is it the same thing as like saying element or individual one? Does it actually understand that's going to iterate through the list and do it to each item in the list?
So not if you send it in here, you will have to have like a little for loop in here to loop through them, but I will show you how to do it to the list itself. Yeah. So now we're going to apply using this lambda to list methods. So there's a bunch of built-in list methods that we can use. So let's start with list.map. Oops. Yeah, list methods. And make it easier for you guys to see the notes or like understand the notes afterwards. Okay, so let's say I have this one list. And it's just a bunch of numbers going from 1 to 10. So map is going to create a new list using a function that returns a new item. So we're basically, the map is going to loop through every single item of that list, of this existing list. And then it's going to apply a lambda to every single one of these items, and then it will return that new list. So I'm going to say new list. And then we're going to call the function map. It's not dot map, it's just map. So this map function, you can send, so you can see what it requires. The first parameter it's asking for is a function, and then the second one is an iterable object. And an iterable object is just something that you can iterate through using like a for loop or something like that. So a list is one of these. So it'll take the function first and then the list that we want to iterate over, basically. So we'll fill in the function in a bit. I'm just going to put my list because I know which list I want to use. Okay, so in here, I can create a new lambda. And this lambda will take an item Again, these are just arbitrary names. You can name this whatever you want. Let's say I want to do, I want to multiply every single item on this list by 2. So I can just say do this. Let me see. Okay. Yeah, I am doing that. I was looking at a different example. Okay, my bad. And then we can print out this new list. And let's see, and comment this part out. Actually, it doesn't matter. Okay, so you see here, the object that came back was of type map. So how can I see it as a list?
Cast it to a list.
Yeah, there we go. So we can just cast it to a list. And then it will show me a list. And now every item is doubled from that original list.
Why did you have to cast it to a list? Was it like an object before?
Yeah, it's a map.
Yeah, it was of type map. So it needed, it just needed to be seen as, what is it called? As a list, yeah. Also,
Oh, okay, thank you.
also, if you just wanted to return it as a list, you can cast it over here. This might get a little annoying to see, but this. There we go. So that one works as well. So you can cast it before when you're creating it, or you can cast it after you've already assigned it to a variable.
Hey, could you copy and paste the example actually as it is? I was having issues running it.
In the lesson, yeah, let me see. So here. I'm just trying to see if there's anything that looks wrong. Okay, it is returning an empty list.
Okay.
Interesting. Isn't it the same thing? So map, lambda, item, and then whatever I want to do here.
Yeah, and if you put if you put line 75 before the for loop, it'll print it.
That is very weird. That shouldn't really happen though. Okay, so now it's not printing every item in the list. Okay. That is an interesting case. So let's see what happens if I try to loop here. So for X in new list, and X. This one out. Okay, so this one printed it out. So it went through, and then it printed out the entire list. With this example, it is possible that it's because it's the same. Mason, you're asking what is the type before? So we can print type map. Not type map, sorry, that's my list. And then let me print this out. So it is taking it as a list, which is interesting.
I think you did
type new
my
list.
list instead of new list.
Oh, thank you. New list. And Ezra, we were asking like why we're using map. So map is a function that allows us to create a new list that is the same size as our old list. But it basically just loops through every single item in that list and does some sort of transformation based on a function that you send into it. So instead of doing a for loop over this list, and then, so this one line is equivalent to me doing for item in my list. And I have to create a new list. So L equals empty list. And then I would say L.append. So we're going to add a new item based off of this item. Let's say item ×2. So instead of doing these 3 lines, I can do this one line and it will automatically map all of these items to a new list and do this, this operation on it. Does that make sense? Awesome. I just didn't want anyone to get lost. Okay, so let's go back to this. So we have our original list. We're creating a new list based off of this. Yeah. Wait, commenting out? Yeah. There we go. Okay, now we're only seeing this. So we're using map to create a new list where it multiplies every item by 2. And then we're printing the type of the list just to see what it is. And now it's type map like we expected. We can loop through it and just print every item, or we can print the entire thing. But the only thing that we need to remember is that we have to pass it to a list, which then removes it. That shouldn't be happening. If anyone sees what I'm doing wrong, please tell me. I think it's just you blame Bing. Nice. Yeah, me too. Did I miss any questions? Let's see.
Is it deleting the list after, if you put it after the for loop, it's deleting the list?
Yeah, it seems like when I print, when I cast it to a list, it's clearing out this. Like
When you put it below, maybe it has to be indented.
not necessarily, because this is just, so if it's indented, it's gonna happen for every item. But this is just, I want to print the entire list as it is. So if I run this again, it's printing out an empty list. Maybe it's rescoping. Maybe. What if I do this? Funny, because this has never happened before. Yeah, when I print it, this is very odd. I'm gonna call this new map. And then I'm gonna say new list equals list of new map. Then we can just use it like that. Okay, so it printed out that it's a type list, and then it was able to go through it. So now if I go here, maybe it's the new Python, I don't know. Okay, well, this seems to now be working. I guess you have to put it in a new variable if you call list. Yeah, I guess. So if I print new map after I did this, it's still a map object. I don't know. I don't think it's worth too much time spent on this. But basically, the map function will give you a map of all of these items with this operation applied to every single item. That is the takeaway here. And if you have the map object that it's returned, then you can do you can cast it to a list, and then you can use that list wherever you need to. Any questions? Questions or clarification? Okay. Let's move on to the next command or the next function. We have a filter function. So I'm going to still use the same function here. I'm going to comment these out just because I don't want it to print. So filter is kind of similar. It applies to a list, but instead of having a lambda that does an operation on an item, it has what you're returning is going to evaluate to true or false based on the item that's in there. So let's say I would want to do new list. I'm going to call this filtered list equals filter. And this filter, similar to the other one, to the map, takes a function and an iterable object. So this function, I'm going to do a lambda that takes an item, and then it's going to check if this item is divisible by 3 or not. How do I know if something is divisible by 3?
Modulo 3.
Modulo, yeah. So the percent sign is a modulo sign, if you haven't come across it yet. This will give you the remainder of a division. So basically, an item is divisible by 3 if the remainder is 0, right? So if I have a 9 divided by 3 is 3 with a remainder 0, so it is divisible. But if I have a 7 modulo, or 7 divided by 3 is going to be 2, because it goes up to 6, and then there's 1 left over. So the result of this would be 1, so it would not be divisible by 3. Here, I can set it in my list. I'm actually going to cast it over here to make my life easier. And then I could either iterate it through X and filtered list. X, and if I wanted to, I could also just print the filtered list as well. Okay, then we can run it. And there we go. So it took the list of numbers 1 through 10, and it only gave me the numbers that are divisible by 3. Any questions on this one?
Could you show where the Boolean comes in?
So this is a Boolean. Basically, what this lambda function is supposed to return is a true or false. So item, let's say item is 6 modulo 3, like it's basically asking, is it equal to 0? This entire thing will evaluate to true if it is. If not, it will evaluate to false. So if it's true, it will include it in this filtered list. If it's false, then it will not include it in that filtered list. Make sense?
Yeah.
Awesome.
I have a quick question about that lambda function.
Uh-huh.
Are you only able to do the condition because it's coming after a filter? Or can you, like if you were to use that for the new map up above, is that?
Yeah, so let's try it. It should not work. Because map wants you to return, and I mean, okay, so let me get back. So what do you think will happen here? If I'm checking here, if this item in the map is divisible by 3, so this is returning true or false, what is this new map gonna look like?
It's gonna be a bunch of Boolean values, right?
Exactly. So it's just gonna, instead of returning actual numbers, because that's what our previous function was doing, this is just returning trues and falses. So if I run this, we should get a bunch of, yeah, there we go. So 1 and 2 are false, 3 is true, and so on. So you can do the function, it just depends, what do you want the end result in your mapped list to be? Great questions. Any other questions?
How efficient are these functions?
I would say pretty efficient. I am not sure of the actual, like, the actual number or like the actual complexity of it, but typically the built-in ones are pretty fast.
I was able to read something that said that these functions are built on C, so they're faster than a for loop.
Huh. Good to know. Good to know. Yeah. Yeah. These filter functions are typically faster than, yeah, just looping through everything.
So that's what I was just looking up, because when you make the iterator, you're making the iterator be faster than a loop, faster than a list rather, right? Because then you can use it and you don't have to go back to a loop. But you then have to just cast it into a list. But apparently the list function, it's definitely faster than the for loop. It's even faster than list comprehension, which was like n log n time.
Yeah.
So it's got to be doing something in C with Python to do that. So that's not too bad. But it'd be the question of making, if you just made it in list comprehension the first time, it might still be faster than doing both operations.
That's very interesting.
Yeah.
Thank you. Yeah.
It's honestly kind of frustrating that like they didn't just like write these things out in very specific. It takes, you know, C, and this is what's the faster side of it, because it is kind of difficult to research that kind of stuff. There's a lot of mostly Stack Overflow, people just clocking in on their computers.
Yeah, that's, yeah, we'll see next. So is it next week? No, the week after, week 3. We're gonna talk about like time and space complexity, like the big O of whatever. And yeah, some operations are way slower than others, as like the input size gets bigger. Yeah, so we'll keep it in mind, or you guys should keep it in mind when we go into 2 weeks from now. Yeah, any more questions about the filter or map? Okay. So the second to last function that we're going to talk about is filter. Sorry, not filter, we already said that. Reduce. So reduce is a function that takes a list and it creates a single value out of that list. So you can use it for a function that like gets the sum of something or gets the product of like that entire list. So any aggregate type function, so adding, multiplying, stuff like that, you can use reduce for. So I'm going to still use the same list. I'm not going to recreate a new one. Let's say I want to get the sum of all of these items in this list. So I can do sum, For reduce, I do have to import a library. We will talk about imports and stuff like that in a bit. But typically, if you want to import a library, you put it at the top. So import func tools, like function tools. So this will allow us to do reduce. So to access reduce, we say func tools dot reduce. And then this reduce function will also take a function and then an iterable, yes. Object, okay. So here I have my lambda. This lambda is going to take in 2 arguments this time. So it's going to take in the variable that we are gonna keep track of the sum in, so the aggregate variable. And then it will also take in the item. So the first one is always going to be the variable that we're holding the result up until that point. So basically it starts at, I think it starts at 0, and then it keeps adding or doing whatever operation you ask it to onto the aggregate. So here I can say aggregate plus item, and this is for every single item in that list, and then I can give it my list. So now if I print sum, basically sum will give me the aggregate after the entire list has finished adding things. So if I run this, I get 55, which I'm going to just assume that it's correct. I'm not going to add them all, but yes. We can change it to multiplication. So if I want to find the product of all of those items together, then we have this number. And if you notice, we don't need to cast it to anything because this is just a singular value now. It reduces a list to one value. Questions?
Yeah.
Did you have to, what was that first thing? Oh, sorry, I was gonna ask, like, what was it that you imported again? Was it func tools or what was it at the very beginning?
Func tools.
Func tools, okay. You just
Yeah.
put import func tools.
Yep.
Thank you.
Yeah, someone else was gonna ask a question.
Yeah, what's the difference between that and just using sum and then the prod functions built into Python?
Which functions? Sorry.
Sum and product, the built-in Python functions?
Oh, I haven't used them actually. So let me see. So product.
It's like math.prod.
So those are part of the math library. They're not really built in. I mean, the math library is like you don't have to install it from the web. Same with func tools. These are libraries that are automatically included when you install Python. But you could probably use the same, the math.sum. Is it just sum?
I think it's just sum without, it's just sum by itself.
Okay, yeah, we can look into it, but I think it's possible that the sum function in math will also do the same thing. It'll take this. But this would be, it would tie you down to just getting the sum or just getting the product, where here you can do any sort of operation to this. So maybe I want to add item plus like 5, and then I want to multiply it by this or something like that. Then you can do, this basically gives you a little more leeway with what you can do.
Yeah, essentially things like sum or product in math would be defined as a specific, like basically they're like using map, filter, or reduce, but with specific arguments, and map, filter, and reduce will work with any arguments. You give it your own function, it transforms it in any way. So it's not just sum or product, even though those are good examples. It can be any sort of transformation.
Mhm. Yeah. Any other questions?
Yes, so right next to lambdas, you said that's the aggregate variable.
Mhm.
Could that be like a variable that's initialized prior to that? Or could that be like a number, like the number 1 or 2? Does that make sense?
Yeah.
Yeah.
Let's say if it was like starting it at 3 basically and using it. I don't think so. So when you're creating the lambda, this is a new function now. And this reduce function will only like it doesn't really, so these parameters that you choose, they're not going to be taken from here. So it's like when you're defining a function. So let's say I'm doing my own reduce, and I have an aggregate and I have an item that gets taken in. So this aggregate will never know about this unless you call reduce and send it in. But the way this function is written, no, you cannot.
Okay.
Yeah. So with reduce, you cannot specify the aggregate, like where it starts off. I think it just starts off at 0.
So you can't define the default like within the lambda. You can't do like aggregate equals 3 right there in the function.
Yeah, let me see. So Python reduce aggregate set default. Yeah, this is just it seems like you can't, just off of my first Google, which isn't always the correct one, but we can look it up a little more. Oh, Chase, you put a pretty good resource in here. Awesome. Thank you. Okay, any other questions about reduce? Or did that answer the question?
Yeah. Oh, go ahead.
Sorry, I clicked on here on a
yes.
Google. Was anybody still asking about the speed of reduce? So I found it from Real Python. Apparently sum is much faster than it. So
Okay.
it's slower, but it still gives you that option to make a unique one.
Mhm.
And it's still a good question whether it's then still faster to use as the for loop if you're gonna have a really complex function.
Okay, good to know. So some, if
The
we're just
sum and products would be the preferred ones if you're using that for a simple thing.
yeah.
That's pretty good. And apparently they are faster than the same for loop with
Mhm.
making it simple. So I think that's a good question, but
Yeah, awesome. Thank you for looking it up. Yeah. There were a few more questions that were.
Yeah, I'll ask. I had a question. So it's kind of similar to my last question about the lambda function. Whether is the lambda being like modified by the reduce or by the filter, like the format for it? Because I thought before we used lambda and we put in 2 parameters, I guess. And so when we used it the last time, I thought we had to give it 2 arguments.
Here for reduce?
Well, not for this one. That's why I'm saying it. This one seems different than, if you scroll up a little bit, like, I thought you did an example where you created two.
This one,
Someone asked, can you put as many as you want in there? Yeah, that one.
yeah.
Uh,
So you can add as many. I believe that like these functions are gonna expect a function that has a specific amount of variables.
Okay,
Like, yeah, so when it's calling it in the backend, this is gonna take this function and it's going to take this list, it's gonna go through the list, and for each item, it's going to send it into this lambda. So map only requires one variable, whereas
okay,
reduce would require two because it wants to keep track of an aggregate.
okay.
When that was
So the
true, right?
functions are changing the format of the lambda.
Say it again.
The functions that you're using are changing the format of the lambda.
They are not changing it, but they're describing it basically. It's telling us like, this is the format that I need. But yes, that is why we are changing the
Okay.
format of lambda, yeah.
Okay. Thank you.
Of course.
I have a question
Uh-huh.
regarding the lambda. So the lambda just, I think the lambda is to figure out the true or false, and that execute the program when there was true, right?
Execute the
wait.
program in what?
When there was true or not. No,
When there were
wait.
two.
Yes. So
So the lambda is basically just a function. And this function will take, so for the reduce, it needs to take two arguments,
yes.
or for some other ones like filter, it will only need to take one. And I don't think I understand your question, I'm sorry.
It's fine.
No, you can ask it again.
Actually, I can't get the line 90s.
Line 90,
Yeah.
like you don't understand why we're using this, like the two here?
Yes.
Okay. So lambdas are just like an anonymous function. So instead of having to define an actual function, you can do this, but you can actually just define a regular function and send it in. So let's say this one is going to be my reduce function. And this function, because I want to reduce it, it has to keep track of a variable that it will always add something to, or it will always, so it's pretty much like if you have a list of items and you like the one here, this one. So I have a bucket that holds the sum, and I'm gonna say whatever the sum starts at 0, so 0 plus 1. And then so now my aggregate is 1. When it goes to the next item, I'm gonna add 2 to the aggregate, so now it's 3. And then I add 3 to it, now it's 6. So I need to hold a variable that will hold on to the answer as I keep going, and I keep adding to that. And at the end, this reduce function is going to return this aggregate, so the sum of everything so far, and that will go into whatever variable I'm catching it. And so here I can hold my aggregate and then an item. And this function, I'm going to just add everything. So aggregate plus the item from my list. So I'm gonna just copy this over so we can see it closer. So here. So if I want, instead of all of this, I can just put my reduce function here. So this should still work. Oops.
Oh, I got it. Thank you.
You got it, you said?
Oh, yes.
Awesome. Oh, I have to return. Okay, so yeah, it still does the same thing as long as you return it. Awesome. Other questions? So Julie, your questions, Lambda can be understood as a placeholder instead of creating a function. Just to use these methods, I can use the Lambda indirectly. Yeah, so basically instead of holding a function in your entire, like in your code, in your file, and you're only going to use it in this one instance, you might as well just use a Lambda, because then you can just write it in line and you don't have to you don't have to worry about defining an extra thing on top, because you already have this one line here. So since it's a very simple operation, you might as well just keep it in this one line. Awesome. Any last questions before we move on to the next one? All right. Oh, was someone going to say something?
I don't think it's very important, but if you just did aggregate plus item, this would technically work for strings as well, for like concatenation, right?
Yeah, yeah,
So you can put in like commas or anything else in there.
yeah,
Kinda just-
exactly. I don't know if
Join is probably the base case for that.
yeah, I don't know if reduce would be the fastest way to do it. It might be. There might be a better function that's specific to strings, but I would have to look that one up too. But yeah, in theory, it would definitely work. Item. If I have my list is, let's say it's just a list of letters. So this. Okay. And yeah, it puts all those strings together. Okay. So the last list manipulation function that we're going to talk about is sort. So if you have a list of something, so let's say I have a list of objects. If it was a list of numbers, you don't have to use a Lambda, you can just sort it and it automatically does it by just, by number order. And if you have a list of names or letters or something like that, it'll also just automatically do it by like the alphabet order. But if you have something a little more complex in your list, and as we see here, we have a few dictionaries, how do we sort this? So this one is actually built into a list object. So if you say people dot sort, this is a function. For this sort, key is going to be what is it called? Key is going to be what your Lambda is. So it's basically asking, what am I sorting on? So here I can also have a Lambda as usual. I can have item. Or let's say person, because this is, I already know that this is a list of people. So I am basically setting up the condition of like, what am I sorting on? What am I trying to figure out? So I can get the person from this list. So this person will end up being one dictionary. And let's say I want to sort by age. How would I access the person's age? If person is a dictionary and the dictionary has an age key.
Bracket age.
Yep. So person square bracket age. And that's pretty much it. This is as simple as that. And if I now print people, to remove the space. So I can print this before and after the sort. So beforehand, it was 44, 49, and 35, but after the sort, it changed the list to be 35, 44, and then 49. So this is one of those functions that actually changes the list itself. So if you're calling .sort, it will actually change the order of the items in that list as it is. Let's say we wanted it to be in reverse order. You can add another value here, and it's called reverse. Reverse or reversed? No, it's reverse. If you put reverse equals true, that means it'll do it in backwards order. So now we see person with 49 and then 44 and then 35 here. Awesome. Okay, so if you didn't want to actually change this original list, you can use a function that is similar to the ones above, that is not like attached to the list object. So this would be sorted. This is just a function where you can send in your list. So my people list. It's a little confusing because it's backwards compared to all the other ones where the lambda comes first and then this one comes afterwards. But this one has the same basic way of doing it for here. So like key, it needs a key. And then let's say I don't want to reverse it. I just want it to be as it is. So if I do this, let's see if it actually changes the list itself. So we look at it and we see no, it did not change the list. So people.sort would actually change the people list. Sorted does not, so it will return a list for us. So you see here, if you hover over this function, it says return a new list containing all the items in ascending order. So I would say new people list, people sorted, and then if I print new people list, this should be sorted. So 35, 44, and 49. Questions?
So I ran into a long problem with this, like I think a couple days ago doing some problem, because I was misunderstanding the key as more of a sorting algorithm itself, as opposed to just a value that's going into the algorithm. So I think I got confused because you're passing in a function, but the function is just restating what that value that the sorting algorithm is going to use. So instead of using the person, now you're using person of age. So you're using the age instead of the whole object.
Yes, so you're not actually specifying like this is like age is less than something, or I don't know, you're not specifying like a specific operation or something.
With the reverse, you can specify which direction it goes with it, but it's just a number. And it makes a lot more sense when I think of key being a length. It's another thing you could throw in there, some other little thing like that. Anything that returns a value for each of the items.
For, sorry, which one?
Like the key could be the length of a string. And it would then, or the length of like lists inside of a list. And then I'd be sorting it based on how big the length is, but still giving it a value for each of the items to compare.
Yes.
Is that why this is faster than other sorts and it's faster than O of N? Do you know anything about underneath the hood, what it's doing?
I do not. We can.
It's got to be because of this other value that must make it easier to sort whatever it converts it into.
Yeah. I think it's because it doesn't actually go through, like go into the dictionaries. It just compares the values. So basically, this key is going to it's going to go through all of these items, and then each key is going to be the value equivalent of this like object of this dictionary. Yeah, so like you said, you're right. I do not know though how it works under the hood.
On line 117 inside those parentheses, key equals and then lambda, that key equals, that's up to us to set, right? It doesn't need to be. Key is not like a specific keyword. It's like a parameter, just like anything else. It could be item equals lambda.
No, so key,
Key.
yeah, so the sorted function takes in, has a keyword argument called key.
Perfect. Okay. Thank you.
Yeah, if we remember from yesterday when we were talking about different types of function arguments, yeah, so there's a keyword argument. That means that if you look at, actually, if you hit command and you click on a function, it'll take you to the source code, like the actual code of that function. Which this doesn't really help us because it looks, it's very difficult to see, but so this function here, it takes in a keyword argument, and this argument is called key. And it has a default, so that means it's not really needed. So if I wanted to do this, oops. If I wanted to remove it. Just close this out. It's probably gonna break. Yeah, it doesn't understand. So this is what it does. Under the hood, the sorted is just comparing it with a less than. Like, it takes the, like, let's say it takes the first two values of the list, and it says, is this object bigger than this one? Or is this object, sorry, smaller than this one? And if so, then it keeps it in the same place. I don't know which algorithm they're using because there's a few different ones. But essentially it is just comparing things. And when we give it a key, we give it something to compare, and it's easier. So you can't really compare two dictionary items like this, but you can compare numbers, you can compare strings. And I think those are mostly it. Yeah, any other questions? And then we can take a little break. Awesome.